So the title of my talk is a bit of a mouthful. I do apologize, but there really is the need for all of these words, and I'm going to do what I normally don't do, and I'm going to actually read it because there are a lot of things here. So what I'm going to talk about is embracing the multimodal nature of clinical AI deployment. We have heard just a few minutes ago from Dr. Hip talking about all this new technology that we want to bring into the clinical environment, and that's not such an easy task. But what I'm going to be showing you today is a process we've been working on that is based on these things called technology readiness levels, or TRLs, that will hopefully help us to eliminate some of the wasted time and money and effort, and making sure that we're responsible with the innovation that we're trying to put forward. So clinical deployment is simple, right? We can just take our new latest and greatest pieces of software or hardware, it doesn't really matter what it is, and we can put that into the clinical system because, well, I just have this USB port and I can plug it into my computer and everything should work, right? Yeah, to an extent, except for when you start talking to other people or learning about all of the other things that you have to consider when you're bringing in a new technology in a highly regulated environment, like clinical informatics. So what you're seeing here is we think it's a straight line to getting from point A to B, but really, in reality, what it really feels like to an end user and somebody who's brought up technology in a clinical setting is you take 2 steps forward and you go 2 steps back, and sometimes you go left and you get distracted, and so on and so forth. So we want to at least straighten out some of this curve, if at all possible. So a little bit of background. I apologize if this is a little duplicative, but I think it suits my purpose. So in the Department of Lab Medicine Pathology, where I'm at, we actually have a number of different divisions within them. And in each one of those divisions, they have consultants. And those consultants have different levels of expertise in their different fields. So, for example, we've got 68 faculty consultants in anatomic pathology alone, whereas we only have 5 consultants in the core lab services. But in all, what this means is we have 177 consultants, 177 pathologists that are all excited about their job, and they're the best at what they do, and they want to bring new technologies to fruition. So if we start with that 177 consultants, that's really just the tip of the spear, because we have at any moment over 1,000 tests that are live. And these are tests that are offered clinically. There's websites, and we take orders in from the outside. There's people to run and process the samples. And there's IT people to build and maintain the systems to make sure that all this gets coordinated, and there's billing, yada, yada. And then there's the ideas. So there are derivatives off of those existing tests, or maybe radically wanting to change a concept. And these ideas, you go to a conference and people come back and everybody's excited to try this new thing or this new tool, and there are thousands of those. And if you just think about the little tools and the pieces that all have to fit together, I can't even calculate how many moving parts there are. But what you can see at the end here is really the bottleneck in clinical deployment, and that's the people that are actually able to do it. And this number is not finite. It's not enough. And there are a number of reasons for that, and we'll walk through on why that is. So just focusing on algorithms, there are tons of algorithms, and there are consistently being developed every day. Guilty as charged. But these algorithms can be anything from homegrown algorithms. Let's say you and your informatics team have built from the ground up using TensorFlow and PyTorch a model that, let's just say, detects tumor-infiltrating lymphocytes in breast tissue. Well, that's great. Okay. Or you could be on the other end of the spectrum and you could want to work with a company, and the company has their own off-the-shelf solution. So that should be relatively easy. Or maybe you work with them to develop one like we did with this QuantCRC project, where we're quantitating tumor microenvironment in colon. And those two are very different, but neither one of them, if it surprises you, is simple. And that's for different reasons. So I'd mentioned about the consultants, but consultants are not the only stakeholders. So in this sort of diagram, what I'm going to do is I'm going to explain the consultants as researchers, not just as lab directors, because they usually wear two hats. So we've got researchers that maybe they're not associated with the clinic, or maybe they are. We've got the lab directors that I talked about. We've got developers. Developers are the people that program, right? These are actually people usually that are different than the day-to-day operators. So it's one thing to build an AI system. It's another to deploy it clinically and making sure that you've got all of your test plans in and change management, and we've also got quality assurance and those sorts of people. If you're building a clinical test, you're probably going to have lawyers involved at some point, so that way you don't get sued. At the end of the day, it's a business. Does it make sense from a business decision to continue pursuing this test and invest the time, money, and energy that you may never recoup? All this coordination usually involves project managers, like it or not. One thing that we've focused on a lot here is making sure that we have ethicists involved for our tests, because a lot of times you can get a long way down the test development pathway and you could be disproportionately negatively impacting a population that maybe you hadn't considered. So we try and do that early on. Then there's the institutional committees of how many different people do I have to ask to get permission to do something. And then let's not forget the end users, or maybe even the lab technicians that are running these tests and these algorithms on a day-to-day basis. So lots of people that are going to have to get involved if you want to bring together a test. And what makes this even more challenging, other than just the sheer number and coordination of activities that you have to do, is everybody has their own goal. So a researcher, their goal is to discover new knowledge. And usually their metric is writing papers and grants. So there's a lot less incentive to build a model and then maintain it, because the way that the funding model works, it's driven off of innovation and novelty, and investments in the status quo they're not innovative, so you don't score well on NIH grants. So they have an incentive to keep moving, okay? A lab director has quite a bit different incentives, because they want to make sure that they are providing a quality service, because that quality service at the end of the day has their name on it. Their reputation is on the line if that provides a wrong value. They're liable. They could be sued. They could lose their license. They're also responsible for running an efficient lab and making sure that their test volumes are up, and that they can interpret any of the results that these algorithms are generating. And those are all different from project managers. And they're only concerned with get this project done. Well, how do you define the project? And you set forth some resources, you remove institutional roadblocks, you do the value stream, and so that everybody can make their decisions. So all these people, all these different goals, there's another dimension that has to factor in, and that's time. And each one of these different stakeholders, they're all important, but they're going to have different interests in different phases throughout the test development lifecycle. So a researcher up here at the top is going to be more interested on the left side, the early side of the time stream. And once it goes live, they probably really don't care, except for, can I get some sort of a paragraph on how well this test has been doing for my next grant? You've got your coding engineers that may be working throughout, your quality assurance, and your IT operators are going to be maintaining software, keeping it going. Very little engagement from the lawyers, except at maybe one point. So you can see that there are quite a few complexities in the time dimension as well as the people dimension. But I couldn't actually give a talk about data and algorithms without talking about data and some of the complexities around data. When we talk about data, oftentimes we don't usually mean the same thing when we're talking to different people with different resources and different backgrounds. For some, data is anything that's contained in the LAS or EHR, regardless of whether or not you can get those back out or not. But if it's in there, that's the data. But there are also databases. Let's say a lab has a private database that they maintain, or you built a database that you threw together for a software project that you got a paper published. You could have on-prem clusters or cloud clusters, or maybe you have to just back up on cloud, or you want to do some computing on the cloud. And do you have a disaster recovery plan? What happens if there's a flood or a hurricane in Jacksonville and all your data is located there? If you don't have that geographically isolated, you could be in a world of trouble. And this is data you definitely don't want to lose. And of course, there's security measures on all of this, and you want to be able to do business analytics. So it's really a challenging ecosystem that is the clinical data environment. And obviously, when you start to put it all together, and you can start to see how all of these factors impact the ability to get things done. Data, for example, is complex and it's scattered. All of these different data sources that I talked about, there may be multiple copies, there may be multiple derivatives thereof. They each have their own security mechanisms and policies to get into. So just being able to navigate from the programmer's perspective, this can be quite a bit of a challenge, and a lot of people don't really understand why. They think that, well, once it's in the system, it's in the system, and anybody that has access to the system, they have access to it. Yeah, true, but trust me, there's a lot of security for a lot of different reasons, whether or not we agree with it or not. So all of this is to say it's a mess, because it's a complicated process, because there are all these stakeholders with different goals and objectives, and there are different levels of granularity that we have to understand. So that's why it really does take a team. But that's just complaining about the problem, and that's just the status quo. That's where we're at today. So what is it that we're going to do about it? Well, that's what I'm going to talk to you about today, is how we funnel in all of this madness and try and put some structure and order around the process so that we can communicate to people as they're wanting to bring up new tests or a new algorithm in the lab. What sort of process do they need to go through in order to make that a reality? And this next slide is, don't let it scare you, but this is our process. It's called the Clinical AI Readiness Evaluator, or CARE, or AI Lifecycle. And we'll get into some of the more details of it as we go along. But basically, what you're looking at is our technology readiness levels from 0 to 9. And each one of those technology readiness levels has a title. And they fit within different scopes. So down early here in the beginning, you're going to have methods development, maybe proof of concept, prototype. You get into project planning and clinical implementations over here all the way to the right. And then you've got these various tracks. And these tracks are groupings of some of those stakeholders with a similar set of circumstances. So clinical use case, that's going to be applicable to certain members of your team, and certain members aren't really going to care as much. Data, again, different groups, different periods of time at which they'll be interested in. We've got the data pipelining, how you get data from A to B, We've got the code, which is separate from the data pipelines. We've got the whole user experience of what it means to actually use this in a lab from the perspective of the user. Do we have technology infrastructure in place to even accomplish these things? A lot of these AI algorithms are using fancy GPUs and TPUs, but if your lab doesn't have that, your task is a little bit taller, if I say that. Clinical orchestration, this is tying into all the various systems that have to talk to each other, and the regulatory and all your gatekeepers. So that's just concepts at a level in these tracks. And in each one of these tracks associated with different technology readiness levels, we've got these components. And these components are a grouping of ideas that are going to be related to the stakeholders for a particular period of time in the context of, in this case, methods development. You're going to be defining some sort of non-clinical problem. It doesn't have to be clinical at this point. But by the time you get over to, say, product development, you better have your fully defined use case and all of your requirements documented so that you know where to plug in and what the app is going to have to be in order to solve that clinical use case. So we'll come back to bits and pieces of this when it's not so crazy. Here's a much simpler view of what it is that I just showed. You can see we still have the exact same tracks over here, but now we've grouped the methods development, prototype, product development, and we've just kind of briefly summarized the objectives in this way. And we found we had to do this because that first slide is a little too scary, and sometimes it's a little too much to present to somebody at the beginning. I don't think so. I actually like the other one because it shows you the complexity of everything that you have to do in order to get your job done. But this is more user friendly, and we have to do that. So how can we use these sort of concepts? Well, let's take this simpler view of the care process, and let's look at it from the perspective of researchers. So researchers are typically going to be involved in the earlier parts, like I said, the methods development, maybe a little bit of the proof of concept too, since they are the subject matter expert. And there are also other tracks that don't matter to the researcher. They may only care about the clinical use case, the data, the code, and any regulatory information like, did you have an IRB or things like that. So for the researcher, it's actually not that complicated. There are just certain things that they have to be aware of and they are going to have interest in. If we move to the lab director, they obviously have a more thorough sort of interest in the different tracks, but they're going to be more interested on the right side of development. So once we get into the prototype stage and the product development, there are going to be different areas of it. They probably don't care so much about the data pipeline. They need to be aware of it just so that they understand things, because at the end of the day, they're responsible for it, but they may have no real specific questions. They may depend on other people in their team to understand that in detail. But you can see that it's not quite as onerous at this point. So let's go to our third example, which is our project manager. And they're going to only be considered with the product planning, the project planning, really. And that really is, for all of those tracks, they're going to be important because these are the people that are herding the cats, as it were, to get all the documentation in place, to make sure that people are doing what it is they said they were going to do on time and under budget. And their work is going to stop as soon as the test goes live. Because it's no longer a project and they can move on. Okay. So another way we can look at this is we can look at this from the more complex view, but now we're only looking at a particular part in time. So we're looking at the clinical user experience in the prototype development stage in TRL-4. We need to identify users. Okay, well, that doesn't really tell you that much other than, okay, I got a general idea about what you mean when you say identify users. this term is going to mean something different to each one of your stakeholders. So a lab director is going to have some questions about that, the readiness of that technology as it pertains to the clinical user experience. So are there apprehensions regarding user adoption and trust in the model if transparency is not maintained of some of the data? Or what processes are necessary to secure buy-in from end users, such as me as a clinician? Your technicians are going to have different things. Have the requirements been clearly articulated, and do users consider the milestones to be reasonable? So you're getting your end user involved, and you're making sure that their concerns are being addressed. Same thing for quality specialists and informatics SMEs. You're all going to have different questions that you're going to want to answer for each of these components. Now, I'm only showing you one component here, but you saw how many there were. Let's look at another example just to try and hit it on the head a little bit more. So now we're looking at the data component. So systems and storage in app development. So that means you're already really far down the development pathway and you're in TRL-6. Well, your IT architect and your security engineers are going to have some questions about data. Now, this is fundamentally different questions about data than the informatics specialist is going to have at different stages, because presumably they would have been looking at data before you got to this point, right? So you can see how you're separating concerns based on the people and the phase that you're in. So IT architect is going to worry about things like authentication and authorizations and working on those backup strategies and disaster recovery. Whereas a security engineer, who's different from an IT architect, might just be making sure that your computational framework adheres to the institutional policies that govern all tests that maybe your individual IT architect didn't consider. Also, data privacy people are usually involved here, and they'll need to ask about the identification and all those sorts of rules. So yeah, I mean that would be just that one component, and you can imagine all the other tracks as well. And you've seen these questions here and how they belong to different stakeholders. Well, what we did is we actually built a checklist, and this checklist has 328 items on it right now. I think we're going to expand it pretty soon. And we break down these checklist items by persona and by that track or the area. So what you're looking at here is by persona. So the machine learning DevOps team, by far the most questions because we have more of a software focus. So 75 questions are directed at the ML DevOps team. 69 questions are directed at the clinical informatics and 54 with the lab director. So you can see that the weight of questions is not equally distributed. You can also look by area, and we have a data bias here. 73 of our checklist items fall into that data track because it's all about the data stupid. I don't know if you've all seen that little pin that's been around, but it is all about the data, making sure that you understand it and have access to it, etc. But then there's also lots of questions about the infrastructure and the user acceptance criteria and so on and so forth. So there may be lots of tracks, but not all of them are as equally onerous to address. But we actually found this to be a necessary starting point to have conversations, to tell people about the complexity of what it is that they're wanting to get into, and use this checklist set of questions as kind of a way to guide whether or not it makes sense from a financial or a logistical or even a scientific sort of premise. So what do we do with our evaluator? Well, we write the book. So it turns out when you put in a lot of effort like this, there's no way to condense it down to about 3,000 words so you can put it in a journal article. We tried. It didn't go very well. You have to explain things at a more granular level. So we're going to take a different approach with this project and actually write a book on it. Secondarily, and along with that book, we're actually going to publish these checklists because we think they're going to be really helpful, not just for us, but for other people. And you can always add to and remove them. It's not going to hurt my feelings. At least it'll give you a starting point for your clinical deployment. Then share it with the world, obviously. And then the thing that I want to close with is more forward-looking, and then it's things that I'm working on this year, and that is to automate this process with agents. And some of you may be aware of agents, and some of you may not. But as a programmer, I tend to think of people and put them in little boxes, like I did here with the different people, like the lawyers and the developers, etc. Well, with agents, that's basically just a large language model that you give a backstory to and a set of objectives, and those agents can actually work on solving a problem by interacting with each other. So if we look at, sorry, the animation didn't really work out here. All of these different agents, I can program a backstory and a set of objectives and add these questions from our checklist and use a tool called Crew AI to facilitate the interactions between them. Hopefully, I can get a lot of questions answered before having a meeting with all of those people. So I'm all about reducing the amount of meetings if I can, because what happens is a lot of times people don't realize that it's that squiggly line and they haven't thought about everything, but they've put together this nice packet of information. Cool, give me that PDF document that you've written out that has everything that you think is important about your test, and I will run it through my agent-based framework. And my agent-based framework, I'll have all of my different agents. So like I'll have a research agent. I'll say, you're a data scientist, provide me a comprehensive, detailed technical analysis of the proposal, a little bit of a backstory, and then each one of these tasks are one of those questions that they would have to ask in a various TRL stage. And so what you can do with this type of strategy is, given a PDF that somebody wrote or a Word document, I can have all of these agents go through and answer those specific questions without having somebody fill out a form, which is number one, super cool, and potentially even give them back a summary of where they're at on the TRL spectrum with an overall TRL, tell them a summary of what their project was, so that way they can make sure that I had a good understanding of it, and then give them a summary of what the committee thought. So each one of these, like a project manager or a researcher, a lab director, they're going to have their own, I hate to say thoughts because they're not really thoughts. They're going to have their own outputs. And I'm hoping that this sort of self-service approach to looking at how ready you think you are when you want to develop a clinical assay that's software-based in particular, of where you need to be thinking next. And so if I give you this score of a 3.5, well, that means you're in TRL 3, maybe 4. So start hitting the rest of those questions and you can progress. And so now it's a lot less of a black box, and it saved people from going to a meeting just to find out that none of the questions that were discussed were relevant to me and my objectives, or B, it was just kind of a waste of time because they weren't really prepared. So that's the goal. That's the interest that we're trying to pursue over the rest of this year. So that's all I have. Happy to take any questions.
Okay, awesome. Thank you so much, Professor. That was an incredible talk. Let's see if we have any audience questions here. Yeah. Okay, so we're going to have someone come up. The moderator is going to ask a question.
Thank you for your presentation, Dr. Hart. I was wondering, what are some benchmarks that you use to evaluate success in real-world applications using the CARE framework, or I suppose like their efficacy, the efficacy of these AI systems? Thank you.
Yeah, it's a good question. So actually, in that very last TRL stage in TRL-9, once you go live, it's never okay, you're live. What you didn't see is there are actually reassessments that have to happen in TRL-9, and those TRLs look at, is this actually effective, and that could be, is it cost effective or is it clinically effective? These are things that normally have to get reviewed for any sort of test anyway. So it's not like we've added any new responsibilities. It's just, did you think about this because you're required to do this? In terms of the value add and things of that nature, I think that really does depend on every single test. So for example, we do a lot of esoteric testing. So these are genetic tests, for example, that we'll never make our money back on. But we offer them because nobody else does. And that's in the best interest of our patient. So in that case, you can't make a decision on, is this financially viable? Because if it were financially viable, other people would do it. That's the benefit of the nonprofit side of things, of doing stuff here.
Thank you.
Can I ask a question from the virtual lobby?
I appreciate it. Thank you, Dr. Hart.
So I can? Yeah. I really appreciate that swimline diagram that you had of the Mayo Clinic's CARES policies. I think that those guidelines, and I've seen David McClintock talk about some of this, are really crucial in going forward. And, you know, how do you see getting that information out to other institutions and making that more of a gold standard? Because I think it's right on the how we should produce good AI product.
You know, if I had a magic wand, I would. The problem is that right now, everybody thinks they're really different from everybody else. And therefore, that anything that anybody else develops isn't going to meet the needs because they don't understand the situation at where you're at. So I think becoming a gold standard is what happens over time. It's after it's been tested and vetted and, you know, changed for the better. So until you really start making changes based on your implementation, because this is all theoretical. I mean, we've had a couple of projects that have not gone through the life cycle process. They didn't go so well, and that's expensive. And we're kind of hoping that enough times that'll happen that, okay, it really does make sense to make it a policy to make sure that you're going through our AI life cycle. And we are working on that internally. As for externally, I think that is a good question that I don't know how to answer, other than you need to be the champion for your organization and you're more than happy to take everything, or you're more than welcome to take anything that we develop and put out and implement it somewhere else.